So my name is Yan Yang Zhang. I'm from MassWorks. I manage MassWorks robotics product and marketing. So I'm very happy to stand here to tell you how to interface MATLAB with ROS. So before I start, I want to ask how many of you using MATLAB for your robotics research? Can you raise your hand? Great, a majority of you. And how many you want to use MATLAB together with ROS? You see? Okay, almost half, right? So the number of reasons you can use MATLAB together with ROS. One is, for example, MATLAB can provide a tool for you to quickly prototype and verify your algorithms. For example, let's say your manager or your supervisor asks you to do a path planning algorithms. I mean, you can use, develop the algorithm inside ROS, but if you don't have any experience of using ROS, probably you spend 2 weeks of learning ROS, learning Python, but you only have 2 months. You don't want to spend one month to learn all the basic things, right? Now, if you use MATLAB, you learn MATLAB in your first year of undergraduate. You can immediately to use MATLAB to quickly implement and verify your algorithms. Second, another scenario is that I'm not sure how many of you doing medical robotics where safety is critical. You have no space of making errors, right? MathWorks will provide tools for you to help you make sure that your algorithm, your implementation, your code meet certain ISO standard. For example, if you want your code to pass FDA standard, you need to, we have tools to help you to meet that. So now, without talking too much, now I show you how to quickly, easily interface MATLAB with ROS. First, I assume you already downloaded the MATLAB ROS integration package. Inside MATLAB, you see, first line is we create an object called ROS MATLAB from the package you download. You can create or connect to a ROS master. The ROS master can be, if you don't have a ROS machine, you can use your own MATLAB to create a ROS master to learn and experience how ROS works. Or you can connect to a gazebo, a real turtlebot, whatever any device running ROS. Okay, then you can create a ROS node, create a publisher, and add a subscriber to the ROS to the node. And now you can set functions when the data come. Here, can you move to the next slide? Now you have the flexibility of write any MATLAB functions here. For example, when data comes, you do image processing, face detection, for example. Next. Yeah, this is the example I show you here. And I have a demonstration. I don't have time. Thank you.
All right, so my name is Hao. Actually, I have no relation with this product I'm demoing here, except we are friends. So I just want to recommend it because I really like it. So this is a 360-degree laser scanner, and they are all specs. Next slide. All the specs are here. It can scan up to 10 hertz, and it can have a range of up to 6 meters and all that. The really nice part of it is it's really cheap. It only costs like $400 for now, compared to some other competitors. Here is the live demo. I want to show it on the screen, but they won't let me do it. Next slide. So this is supposed to be a GIF animation, but for faster representation, I just put it here. Next slide. Yeah, so this is the ROS environment. It works on ROS and Windows for now. I'm not sure if they have a plan to port it to Mac OS, but I think this suits most people's needs. Next slide. Yeah, right. So this is an actual application the team who developed this LiDAR does. They also provide SLAM solution and all that. I'm not expert of that area, so next slide. I'm not sure if, yeah, these are all supposed to be GIF animation. Next slide. All right, right, this is the, actually I just got this slide several days ago, so next slide. This is the principle, how it works. And these are some of the specs. Next slide, I think it's pretty much it. right? So there are like a lot of details, and this was actually this whole thing was an open source project before. Then these guys turned it into a product. Next slide. I think it's pretty much it. Yeah, right. Next slide. Okay, that's it. So we will be demoing this on a Birds of a Feather meeting. I will put it on there, but just a heads up, my computer doesn't last long. Like the power only lasts for what, an hour and a half now, and I don't bring power here. So if you want to check this out, meet me or Didi. Please stand up. Meet me or Didi Joe at somewhere. Like just find us, and you can see the demo. Thanks.
Thank you.
Hello. So hello, nice to meet you. My name is Oliver. I live in Shanghai. Can you please go to the first slide? Yeah, that's me. I'm even wearing the same shirt. So I live in Shanghai, and I'm working for BMW Connected Drive Lab in Shanghai in the embedded software development team. And I'm here to talk with you about BMW autonomous driving and the usage of ROS. So first of all, I wanted to ask you, did you know that BMW has quite some years of experience in building self-driving cars? And BMW Carity in Munich even develops a ROS-based architecture for autonomous cars and also open sourced some ROS tools. This has been published already also last year on the ROSCon in Stuttgart, Germany. So please go to the next page. So the open source tools they develop you'll find on GitHub. First of all is if you want to cross-compile ROS for BeagleBoard, MinoBoard, PandaBoard, and then you should really try the Open Embedded Yocto project toolchain and the ROS layer for Open Embedded. And second, if you want to use ROS in your real-time system, then you should try the ROS real-time tests in your setup. So this allows you to integrate real-time checks for timers and publish subscribe communication capabilities of your specific ROS project. So this is me. If you're a student and if you have a passion for robotics and autonomous driving, or also if you're a professional and looking for new challenges, or if you just generally want to know more about my work in Shanghai at BMW, I'm looking forward to talking to you about what I'm doing there. This is me. You can find me here around, and I'm happy to talking to you.
So my name is Lars Tingelstad. I'm a PhD student at the Department of Production and Quality Engineering in Norway. And we're working on assembly tasks for aircraft engines. So this is the new Dreamliner from Boeing. Yep. And this is the component that we're working on in a EU 7 framework project called IFACOM. And it's quite challenging manipulation tasks involved in that. And then here's my kingdom that I've set up in the last 6 months. We just bought six new KUKA robots, and we're developing the demonstrator in the IFACOM project using MoveIt, ROS Industrial, ROS Control. And if you want to hear more about it, come see me in IAS 13, the ROS Industrial workshop there in July at the, yeah.
Hello, my name is Leif Gentoft. I'm from Right Hand Robotics. You heard earlier that the iRobot hand from the DARPA challenge is not available for normal people. They had a contract to try to sell a certain number of those to the DARPA teams, and they decided not to commercialize that. Our group is a group of many of the designers from that team spinning out a company trying to change that. So if you want to build an effective hand, many of the existing solutions are very expensive, and they're relatively hard to control. And so what we have here is, if you want to start the video, we've got a hand that's built on the same technology but has been optimized for research use. So what we have 4 different motors. There's one inside of each of these different fingers. You notice that we have soft joints as well there. You've got integrated tactile sensing. And we're developing this as a research tool for the community so that you can have an effective hand that's low cost to install on your own robots. We've got tactile sensing in here. We spoke at ROSCON in 2012 on this technology. It's based on MEMS barometers and extremely sensitive. And between that and between the compliance of the fingers, this means you can very easily grasp a object that has a very random shape. You don't need to know a lot about the object. You can tolerate high positioning errors and high uncertainty from your perception system. So releasing this as a research product, we've got a beta program over the summertime that's just about subscribed. And the base here is also 3D printed, so you can modify that to mount on whatever arm you have. We've got a live demo that I'll be walking around with, so if you're interested in hearing more, please come by and let me know. Thank you.
I'm Kelsey Hawkins from Georgia Tech. So I work with the Universal robots, and if you're familiar with Universal Arms and ROS, you probably have used the current ROS drivers. I've been working on creating real-time ROS drivers that communicate with the C API. So one of the reasons you might want to do this is communicating with the joints at 125 hertz. A lot of people have had latency issues. This should be a lot better on the latency problem. We are exposing both velocity control and the position velocity acceleration control. Eventually, I plan to release torque control. You can find all of my work or most of my work at the repository. It's on one of the branches called the HydroDevel CAPI branch. I've also forked it into my own repository. So if you want to see sort of the latest work, then you need to probably look at my personal repository, also at the GT ROS package fork. Next slide. Oh, actually go back one time. One thing, the link at the bottom has a tutorial for setting things up. It's not great, but it should get you going. All right, next slide. So here's the infrastructure. So there's basically a control loop that will be running on the box. It's fairly easy to take one of the packages, move it over to the robot, compile it. Then you run that. It's running a control loop you see in the top right corner. On the left, on a ROS-enabled machine, you run another loop, control loop, that you see in yellow in the top left corner. It communicates with the real-time controller that's actually on the control box at 125 hertz. And it's all been enabled using ROS control. So I've developed several different ROS control-enabled interfaces, hardware interfaces, so that you can write your own controls using ROS control. And then on any other machine, you can run all of the controller manager, a robot state publisher, any sort of controllers that controller schemes you want to write. What I currently have is forward velocity commands, forward position velocity acceleration commands, and also joint trajectory controllers. Next slide. So I've also developed a GUI, an RQT plugin that allows you to control velocity of the different joints, different speeds. At the top, you can see there's buttons for a dashboard for controlling the power states and fixing the security stops, and that's about it. Check out the wiki and the repository if you are interested in learning more.
Right, hi everyone, I'm Jeffrey. So I'm from University of Tokyo. Today I want to show you this thing. So how many of you know what is RoboCup? I think everyone knows, right? How about RoboCup at home? All right, good. Someone know actually. So it's actually a competition for service robot. So you can see like this is a snapshot that we have on RoboCup at home. Japan Open 2014 on last May. And you can see like there's actually a lot of cute robots out here. So okay, so I'm from Team Kamen Rider. So this is my robot, the tiniest one here. So I'm going to talk about this today. So why I actually built this is because you can see like there's actually many variation, custom made and everything. And this, what we observe is over the years, the participation team is the same. So the same team actually built some improvement and we compete over it. But we would like to have more teams to have more input. So we try to like bring down the complexity to actually enter this game. So next slide, please. All right, so you can see I actually made a prototype out of turtle boards. So you can see down here is actually a turtle board. It's the same, I don't actually modify a lot, but what I put up here is actually, I try to combine all the tutorials and all the basic package, put the mapping, and I also put this is one of the tutorial, the ARM, put it up so that this is actually enough for the entry level to actually enter the RoboCup at home games. So my purpose is actually to open up this platform so that more people can join the event. So that's the idea. So today I would like to bring to you this platform. I would like to see how many of you are actually interested in this so that we can build together, because it's an open platform. So you can see like we try to put in some face, some arm, and so on. Okay, next slide. Okay, so this is the current development. So now talk to a few parties regarding the hardware, regarding the software, and try to open source the whole thing. Okay, then mainly we will, based on Turtleboard, we try to put up, and we try to do some 3D printing on all the additional things. And we'll put up the 3D model as well. And also we using ROS, mainly over here. And for RoboCup at home, we actually talk to the local organizer and we try to organize workshop now, so that to spread to more people to actually know about this. And we're currently starting from Japan. Okay. Okay, something interesting is we also try to think how to actually reduce the burden of computing on board. So we actually try to think of how to build up actually a cloud architecture to actually do the processing. And of course, with Android, and we finally want to think of how to actually build something that we can build apps on it. Okay, for more information, this is my email, my office email, and that's my team page. And I'm going to create a new domain for this project soon. Thank you very much.
Thank you. Sachin.
Hi, I'm Sachin from SRI, and I'm here to give you an update about Move It. Move It is up and running and doing pretty well. There's over 65 different robots. We did a survey last year, and from the responses, we compiled this list of robots. And since I've been at ACRA over the last few weeks, over the last week, and today at ROSCON, I found out there are even more robots running Move It. So if you haven't sent us the name of your robot, please do so. We'll put it up on the website and add it to the list of robots running Move It. This is a montage video that we had put out at the beginning of the year showing a bunch of different things that are being done with Move It. I guess the video didn't play. Okay. So if you go to moveit.ros.org, it's the first video on the main page, so you can see that. I also wanted to say that if you're using Move It in the DRC, feel free to email us and ask us for particular feature requests. We are willing to support teams that are in the DRC, and we would love to see how you're using it. The other thing I wanted to mention was ROS Control, which we've been using a lot of lately at SRI as well. I know there's a bunch of organizations that have been contributing to ROS Control and using it. ROS Control provides you a generic framework and a solid base of controllers that you can start using with your robots. If you're interested in more standardized approach to control, I would encourage you to look out to check out ROS Control as well. The next one. So these are just a few of the robots that are running ROS Control right now. I think there might be more, and if there are, come and let us know that there are more. There's Ream, Taurus, it's at SRI. Thanks to Dave Coleman, you can now use ROS Control almost by default with Gazebo, UR5, and actually ROS Control was originally intended for the Redwood ARM, which I don't know what's going on with that anymore, but that's what it was intended for. Thank you.
There's been inquiries by a bunch of groups. So I got the shirt on to prove it, move it. Thank you, Sachin. And just other thoughts is that so Move It was originally made at Willow Garage typically robots just like arms, maybe industrial robots or with wheeled bases, but the wheeled bases were kind of left to the navigation package. And so I'm not working with Atlas, but as we heard earlier, there are some teams who have tried using Move It with mixed success on bipeds. And so one thing I'm working on this summer, I kind of want to just open up for collaboration, is adding more features to Move It that will feature full body manipulation. So maybe reaching for things while bending the legs or moving the feet. And I'm working at JSK this summer with Kei Okada. And so as a joke, I translated it to Japanese. I think I got the direction right this time. Last time I had it said, go move it, which is also good. Or no, it move. It said it move last time. So some of the challenges, is, the inverse kinematics architecture previously had been just for a single kinematics chain. And so we want to have a tree or maybe even a graph. And so we've been working on having multiple tips, where a tip is like an end effector feet. Then, of course, there's a problem of tools like OMPL. They still might start suffering from high dimensionality when you get to the full body dimension space, or particularly with dynamics, then you're doubling that again. So you're thinking like 60 or 70 degrees of freedom. And then we can't really avoid the dynamics for a lot of things. So we're looking into how to add these extra constraints to the planning step using classic tools like RRT. And perhaps there's definitely like a big community out there with the control side of things. And so will the existing tools and Move It using things like RRT be satisfactory for planning with the biped? We'll see. But I mean, it's definitely been a lot of research in the past. We want to continue looking into that. And then, things like choosing footsteps and contact points. So there's a big momentum behind this. As I mentioned, JSK at University of Tokyo. There's a couple guys at NASA working on the Robonaut to get that integration. PAL Robotics is actively pursuing it, and Sachin can't talk about it, but there's some stuff there maybe. And so just want to encourage, we encourage you there. And then finally, I guess it's just an overview slide of different components that we've had to put in, like new constraint samplers, foot interpolation libraries. And actually, we've been integrating with our presentation, our keynote earlier, with the EUS Lisp software that they have. They have some amazing many years of research, and as I said, a lot of manpower's gone into it. So we've actually used things like their walking padding generator. So yeah, my name's Dave Coleman, and please come up and see me if you want to discuss pursuing that. Thank you.
Hi, I'm Vincent Trabot from Aldebaran Robotics. I'm managing the perception team over there, which is vision and audio stuff. We're focusing on interaction and emotional robots. We just released Pepper yesterday with SoftBank. If you haven't seen it, just check it out on the news. I'm also part of the OpenCV Foundation. I'm maintaining a lot of packages in ROS. And I used to be at Willow with Sachin, Dave, and all those nice people. We have our own middleware. It's called Naoki. We don't use ROS, but that doesn't mean that you cannot use ROS with our robots. Mostly Nao and Romeo too. The bridge exists. It's been a few years now. Armin Hornung from Octomap and Seren Leminion are probably the main guys. I mean, there were people from Boston. It's been going on for a while. It's fairly simple. You just need 2 lines to install it. There's a package manager that's been created for that, Robot PKG. It's fairly complete for the ROS support. Has a dashboard plugin, URDFs, meshes out there. Gazebo plugin and a Move It plugin just came out. So go ahead and use those. The community is also pretty active. Like there's some cool stuff that just came out too. A 3D helmet that you can print, so they can add a Kinect or an Asus or stereo camera on top of your robot. And even a guy managed to add another CPU on the back of Nao, so that's, you can really have a good CPU there. There's a SIG. Please join it. There's a lot of information there. Next slide, please. And I'm Vincent Trabot. Just come ping me. I'm going to be here all day. If you want to talk about Aldebaran, anything there. Now that we released Pepper, I guess we can talk a bit more about it. If you're looking for a job, if you're looking for an internship, please come to me too. If you just want to know about OpenCV, about the packages I'm maintaining, I'll probably do a better feather for vision, just really generic stuff to keep you guys updated if you're interested. And obviously, if you want to talk about ROS, well, I'm here. So thanks.
Ben.
Hi, so I'm Ben Kehoe. I'm a grad student at UC Berkeley, and I just threw this together, so I'm mostly going to read off these notes. So I work on cloud robotics, and in particular bringing the software as a service paradigm into robotics in what we call robotics as a service, which we pronounce RAS because it can't be ROS. Yeah. And so as Professor Okada mentioned, that version hell is tough, but it's kind of a fact of life. When you're sharing algorithms, you have to sort of download, build, and you've got conflicting dependencies, and it's just a whole mess. So the solution, we think, is to provide algorithms as services. And this is sort of the Google Docs versus Microsoft Word paradigm. And a good example of this is the DRC sim, which is provided sort of in the cloud as a service that you can use. And so it's easy sharing. You can share an algorithm, and there's no downloading. If there are improvements to it, you get those transparently, and it's all fine. And you also control the environment when you're creating it so that you don't have to, the dependencies that you have, you can manage just in one environment. And then this is great because then you create an algorithm, you want people to use it, you just provide it as a service, they can just test it out, anybody can test it out if they want. So recently we released ROStful, which is a lightweight framework for integrating ROS with RESTful web services, both on the client side and the server side. But what we're building now is sort of a system that's going to be easier for users. That's a client that will allow you to connect to web services and integrate them. And then also for creators, that you can package up your algorithm in sort of an easy way, wrap it in some simple Python code, and upload it, send it to us, and then we can put it in the cloud and make it available to other people. So the thing is, we need services. We want to be able to provide a host of services when we introduce this. So if you have algorithms that you want to make available as services, please contact me. There's sign up at the website. You can email me, and there will also be a cloud robotics bird of a feather thing. So yeah, thanks.
Hi, I'm Manos from Sado Robotic Company. First slide, please. As a quick presentation for our product, Ronex. Ronex is meant to help people that want to build their own robot and do not want to use soldering gun to make PCBs or write low-level drivers. Available modules are the Bridge, the general purpose I/O module, and the Ronex SPI module. The last, this is an example of a configuration, and so how you will access joints in a robot that you made to the Ronex module. I see that we'll specify here the joint that is Ronex control, and you can map it here, the position, effort, or command of the joint to specific pins. And a very quick example here, how you can use Python to publish to a topic to control a motor, for example, or subscribe to a topic to get an analog value. Ronex is compatible with ROS control, as was mentioned earlier. All the software is open source in GitHub. You can fork it and modify it. There's also a possibility to hack the firmware on the Ronex. Unfortunately, you have to buy it if you want to use it. It's available either from Sado or Guitec, one of the sponsors. Again, Manos, anybody wants to know more about this or the Sado Robot Company, we make another cool product, the Sado Robot Hand, then find me.
Is that part of your URDF?
Hmm?
Does that go in the URDF?
Yes, it goes at the end of the URDF that describes the robot.
Cool.
Exactly.
Thank you.